Welcome back to my channel. Today I will discuss about the 2020 paper 2 max T question, part 1. First, a function f is defined by fx equals to x plus 3 squared minus 1/4. This is when x smaller than negative 4. So we know that in this domain, when x approaching to negative 4, negative. While when x equals to negative 4, the fx is equals to negative 3 over 4. When x greater than negative 4, fx is equals to x plus 4 divided by 3 minus sub x squared minus 7. So this is the term when x approaching to negative 4 positive, which means in this term, x can be negative 3, negative 2, negative 1. In this term, x can be negative 5, negative 6, negative 7, and above, okay? So A, find the limit of fx of x approaching negative 4 is exist. First, we need to find the limits. While A is used to serve B, determine whether f is continuous at x equals to negative 4. Because one of the conditions for f to be continuous is the limit of x approaching to negative 4, fx must be exist. So we check the condition first. Limit of x approaching to negative 4 negative, we will substitute our fx into this term. Because x is smaller than negative 4. This is what negative here means. While when positive means here with x greater than negative 4 but approaching to negative 4, which means x can be x equals to negative 3.9999 maybe something, but it's always greater than negative 4. So we need to substitute these terms inside here and substitute this term inside here and replace the x into negative 4, replace the x into negative 4. We will obtain the limits of this both, and then we compare to the limits. We compare to the limit to check whether the limit of fx negative 4 exists or not. And since limit of x approaching to negative 4 fx doesn't exist, we can know that since this one doesn't exist, f is not continuous at x equals to negative 4. If you guys want to find out why it is discontinuous, you can actually plot out the graph. You can actually plot out the graph by using this 3 piecewise defined function, and you plot with the point by observing the point negative 4. You can find out the curve is actually discontinuous, is broken one part by one part. Question number 2. Find the equation of the tangent to the curve sine x minus y equals to x cos y plus pi over 4, which passes the point at pi over 4 and pi over 4. This is x and this is y. Sorry for my handwriting. This is actually represents a pi in terms of x and pi. First, we need to find out the equation of tangent, which means the dy dx is actually the gradient we need to find out. So what is the equation of tangent? When you have a curve, you dy dx you will get the intersections point between the curve and the straight line here. Here we are calling this one is the line of a tangent. This one is our line of a tangent. And at this point is our dy dx equals to 0, which is the local minimum and the local maximum point, whatever. So we need to check the gradient of this point. Sine x minus y is equals to x cos y plus pi over 4. And we try to differentiate both sides. We differentiate both sides. In terms of x terms, we d dx both sides. Here and here. We d dx both sides. And we will obtain this one by using our multiplication rule. U prime v plus v prime u. I believe this one we already learned during our Form 4, Form 5 additional mathematics. So after we differentiate, we can obtain in these terms, and then we separate out our dy dx, and on our left hand side, separate out this whole thing on our right hand side. Substitute in x equals to pi over 4. Substitute in y equals to pi over 4, because we are checking about which passes the point pi over 4 and pi over 4, which means this line is actually passing this point. This is the point we are passing through. So we can substitute this point inside to find out the particular solutions. To find out our gradients. What is our gradient looks like? Because this is one of the point in our line. So finally, we found out that our dy dx is equals to 4 over 4 minus pi. So this is our gradient. And we substitute equals to y minus y1. This is actually our y1. We can use back this point. This point is actually since this point is on this line, is on our equation of tangent, we can reuse this point again inside our general equations and in our particular equations. So this thing is x minus x1, y minus y1 times the dy dx, your gradient inside. So this is our particular solutions. Y equals to 4x over 4 minus pi squared 4 times negative pi plus 4. Why I say this one is a particular solution? Because this solution is valid when this line crossing through this point. So that is what we call the particular solutions. Number 3, using the substitution u equals ln x shows that integration of 1 until exponent is 1 over x times with ln x plus 1, ln x plus 4 dx equals to 1/3 of a ln 8 over 5. Since they are giving us the hint, substitute u equals to ln x, so we better use the hint given. So when we differentiate this term, we will find out that we move the ln to our left hand side. We will find out the ln is actually the exponent, and we differentiate in terms of x. We will get these terms. After that, we can cross out this 1 over x dx here, substitute with the du here, and then but remember to change your limits as well. If you didn't change your limit after you done all this thing, you must remember to convert back into your x domain. If not, you will mistakenly put in this limit inside your u domain, and inside your u domain you will obtain a wrong answer eventually. So better we change it first. So we will get ln e, ln 1. Ln e you will get back 1, and ln 1 you will get back 0. So when you solve in these terms is actually two different roots. You have two different roots in terms of u, which means you have a cross y equals to 0 at u equals to -4 and -1. So this is the meaning, -4 and -1. Means that this is actually, we need to split it and using the additional rules of the integrations to solve it. So we use a partial fractions to split this term. Partial fractions is do in this term, and remember this symbol means equivalent things. So after we obtain our constant a and obtain our constant b, we substitute back, we will obtain this thing. So if you don't believe why we can obtain this thing, you can actually combine these two terms together by cross multiply each other. See whether you can get back the same thing. Okay. So this is our cross validation method, one of our validation method to check that our partial fractions is doing correctly. So after that, we integrate one by one. This one using the integration of ln properties. This one also using the integration of ln properties, which means our integration of our fx, of our f prime x divided by fx, we will eventually get back our fx using this property. Okay, so solving this question, we will finally get our 1/3 ln 8 over 5. And please remember, this is a simple mistake which usually can be triggered. For example, 1 over 3 ln 2 plus 1 over 3 ln 4. It doesn't mean that this one is 1 over 3 ln 6. It is not simple addition, like 2 plus 4, I get 6. No, this is incorrect for ln property. Plus, in the logarithm world, plus means multiply. So 2 multiplied by 4, you will actually get 1/3 over ln 8. And minus in logarithm words means divide. If ln 2 minus ln 4, it doesn't mean ln -2. That's invalid. It means that ln 1 over 2. So that's valid. Please avoid this kind of mistake, because this mistake it doesn't work. Thank you.